Everything in networking always comes back to the OSI model, so let's revisit this again. As you remember, the layers of the OSI model separate different processes, making it easier to change a protocol at one layer without impacting the other layers. As you can see here, traffic flows down from the application, and as it does, different things are done to the data. What we will look at today is how the data gets converted into a packet. From the application to layer 5, the data is just a stream of information. At layer 4, the transport layer, the data is converted into a packet of data. This packet is actually addressed to its peer transport layer, layer 4, in the destination computer. Think of this packet as an envelope in which you put information. Now the transport layer packet is sent to layer 3, the network layer. Here the original packet is actually placed in another packet. This packet is addressed to the network layer in the destination computer. Remember the analogy of your letter? Now imagine you're sending it via Federal Express. You would take the envelope containing your letter and put it inside a Federal Express envelope. This is similar to how the layer 4 packet is placed inside the layer 3 packet. We now have a network packet and send it on to layer 2, the MAC layer. At the MAC layer, we take the network packet and put it inside another packet. This packet is then addressed to the MAC layer in the destination computer. Think of the MAC layer packet as the box in which FedEx places your envelope so they can ship all the packages addressed to the same city in the same shipping container. So, what your computer has done is take the original information and put it into 3 different packets. Why? Well, the reason is simple. It's all based on protocols. Just as an apartment building can have many different people living in it, your computer can have many different protocols or applications running. The different packets are designed to get the data to the correct location. For example, you have an email program, a web browser, and a multi-user network game all running at the same time. Each of them needs to get data to and from the Internet. Each needs to make sure that their data gets to the right place. Now here's what happens at the receiving end. The MAC packet is responsible for getting the data to the correct computer. Once in the correct computer, the MAC information is removed and the packet is sent to the network layer. The network packet is responsible for getting the data to the correct protocol within the computer. Once at the network layer information is stripped off and the remaining packet is sent to the transport layer. Remember, that's layer 4. The transport packet is responsible for getting the data to the correct application. With all this working together, the packet gets to the correct computer, the correct protocol, and the correct application. While this sounds unnecessarily complicated, it's the best way to make sure the data is correct and properly delivered. And, to prevent quibbles from technical purists, to be 100% correct, the data at layer 3 and layer 4 is called a packet, and at layer 2 it's called a frame. But, as I mentioned, we will call everything a packet from now on.